Hi, I'm Alistair, and in this video I'm going to be showing how Dedoctive can be used to complete a detailed forensic GSN safety case analysis. Goal structuring notation is a format used in safety engineering to decompose an argument. It often requires a team of specialized safety engineers days or weeks to construct due to the vast amount of data included and the care that needs to be taken to ensure that the data is relevant and properly cited. Dedoctive's intelligent indexing of huge volumes of complex information solves this problem, taking an analysis from days to minutes. On top of this, it includes full traceability and provenance, with links back to the source paragraph, table, or image, as well as an interactive diagram which breaks down where each element of the answer came from in the source documents. Orchestrating a process to generate this analysis that is both flexible and extensible could be very difficult. This is where our hybrid BPMN and Agentic workflow automation platform comes in, combining the structured nature of workflows using the open BPMN standard, along with the ad hoc reasoning abilities of agents. The combination of our hybrid workflows and our comprehensive knowledge models allows us to do a thorough analysis of a safety case and present the results as a GSN diagram, which I'll demonstrate now. I'm beginning this demonstration on Dedoctive's front page, which is what a user is greeted with when they wish to run a workflow. I'm going to select Analyze Argument and click Start Agentic Workflow. The user is first prompted to enter details in this form. The structure and inputs of this form are actually defined in the workflow itself, which I'll show later. The subject of analysis I'll set to plain X. The collection is also set to plain X. This consists of multiple PDFs specifying information about an aircraft, which has been lexically, semantically, and graphically indexed, creating our complex knowledge model. I'll also set the decomposition depth limit to 2, which means 2 levels to the GSN diagram. I'll now click Send to Dedoctive. As you can see, there's a progress bar at the bottom, which shows the current task that the workflow is on. After a few minutes, the workflow is now completed, and we can see the response here. This is the GSN diagram it generated, which we can inspect further. If we zoom in, we can see the main top-level goal node at the top. This is then decomposed into further nodes, until we get to solution nodes. If we click on this top-level goal node, it takes us to the description. It gives a title for the node and a basic description about the information of the node. We can also show additional information here to see extra metadata about the node. This information is vital to a safety engineer, saving them time by focusing their attention on potential weaknesses in the argument. For example, in this case it states that the assertion can be evaluated as true or false, meaning it's a proposition, and it doesn't have more than one assertion, meaning it's atomic. Therefore, this goal is well formed, so a safety engineer could focus on other weaker nodes first. Another important feature is the ability to view the citations here. If we click this link, it takes us to our file viewer, where we can see the file that was used to construct this information. If we now go back to the response, we can also see a button called Explore Response. This takes us to an interactive diagram, which we call a response map, showing the breakdown of where the answer came from in the source knowledge model. Here you can see the original query and how it's broken down into the various elements and entities. This one takes a paragraph and shows that it comes from this document, which we can view the source of here if we wanted to. Also further down, we can see that this entity leads to this paragraph, which leads to this image, which leads to this document. Therefore, we can see the full path from the original documents to the response that's being constructed, allowing us to verify any claims that were made. We can go back to the response and see that for each node it has these same citations and explore response, allowing us to delve deep into the citation used for each response. Now that we've seen how this analysis can be started and viewed by a user, we'll take a deeper look at how the workflow is constructed within our designer. This is our Dedoctive Designer, an entire IDE for designing and developing agentic workflows. It allows a user to drag and drop various elements in and define their properties to build complex workflows. I'll start by going through the basic elements of the workflow from a development perspective. The first task in the workflow is Get Collections. This is a service task, and inside the Dedoctive service properties, you can see it's an MCP tool. This is a tool call to our MCP server, which is responsible for all of our complex analysis and knowledge building features. Next is Get User Input. This is the user form that you saw in the UI previously. If we expand the web form, we can launch the editor and see that you're given the ability to construct a form, with a preview at the bottom showing how it will appear when presented to the user. Next is the main goal. This is a tool call to our MCP server again, which is essentially an enhanced form of RAG. It includes getting the context from the document collection, accumulating it, and outputting it in a structured form. If we open the editor here, we can see that we have many tools available to Dedoctive Document MCP server. For example, in this instance, it structures the data according to the supplied JSON schema. This JSON output is then inputted into this task. This task is a service task, but it's a workflow agent. So it calls a workflow as a sub-workflow. This sub-workflow is extract strategies and sub-goals. This sub-workflow is responsible for all the decomposition and works recursively. It begins by extracting the strategies and sub-goals, and then extracting each of the sub-step nodes which are completed in parallel. Then, if the decomposition isn't complete, it decomposes further. After it's finished decomposing, the nodes are merged together and the diagram is generated. I appreciate this was very brief, but now that you've got a basic overview of the structure and components of the workflow, I'll now run it, which will clarify how the data flows through and demonstrate the debugging abilities of Designer. To start the workflow, we just click Run. This sets up the session, and it also opens the workflow output panel. This also shows each event that is generated during the running of the workflow, allowing you to see the data flowing through. For example, now that we're at the user form, we can see the data that is currently available at this task in the workflow. If we go to this task, open task data, we can see that the only data available is the workflow mode and the collections. I'll now send this form to Dedoctive. Now you can see that each task is highlighted as it passes through the workflow. At the moment it's completing the main goal MCP tool call. And now that that task is completed, other tasks are highlighted in green. You'll also notice that the event messages in the workflow output are the same as the ones you saw in the front-end progress bar, which allows the user to easily track the progress of longer-running workflows. For example, here it says executing chat augmented completion. This would be shown on the progress bar presented to the user. The workflow is now running through, so I'll fast forward until the workflow is completed. Now that the workflow is complete, we can look into the final task's task data and view the nodes which have been constructed. Here we can see a variable called nodes. This contains a list of all of the nodes, their title, their type, their description, and their provenance, which contains the citations and response map shown previously. We can collapse this and then also see that the GSN diagram HTML is also here, which you saw in the front end previously also. We can also see the form data that was passed in the initial form. If we expand this, we can see that the subject, collection, and depth limit are all here and were used to form the GSN diagram. Another key feature of Designer is dynamic debugging. To demonstrate this, I'll go into the script for merge nodes and add this line. If I now save this in the script editor, this just flags the task as having been modified. Now, if I click rerun, the saved data and events from the prior run of the workflow will be reused up until the task that I modified, which means no additional processing is required to get up to where a change has been made. As you can see, the tasks are being highlighted in grey. This shows that it's simply reusing the data from the prior run. Now you can see that the final couple tasks weren't highlighted in grey. This shows that they were ran normally because of the change I made in the merge nodes task. And you can also see this warning in the workflow output, showing that the changes made to the task was the reason for the rerun stopping. This feature gives us the ability to make rapid development iterations, meaning we don't need to wait for long API calls and can instead quickly modify how the data is used in a later task. That's all for this demonstration of Dedoctive and how we're able to efficiently develop workflows that utilize our intelligent indexing of documents to complete comprehensive analysis of a safety case and generate a verifiable and traceable GSN diagram artifact. If you'd like any further information, a link to our website is in the description of this video.